Hello, in this lecture we'll prove Stewart's theorem in two different methods. In a nutshell, Stewart's theorem yields a relation between the lengths of the sides of the triangle to its CVN. The CVN in this triangle ABC, is line segment AD. Okay? And according to Stewart's theorem, the following equation is true, that b squared times m, here the length of side AB of triangle ABC is equals to C units, the length of side AC equals to B units, side BC equals to A units in its length, the length of line segment BD is M, the length of line segment DC is N. And again, the length of the CVN AD is D units. And according to Stewart's theorem, the following equation is true, that b squared times m plus c squared times n equals to A is the length of side BC of triangle ABC. We open brackets. Inside the brackets we have d squared plus m times n. Again, according to Stewart's theorem, p squared times m plus c squared times n equals to A. We open brackets. Inside the brackets we have d squared plus m times n. Okay, so we'll prove Stewart's theorem in the first method. In the first method, we'll do a construction from point A. We'll draw perpendicular on side BC of triangle ABC. So say this angle equals to 90 degrees, and this angle is also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and BC as E. We will define the length of line segment ED, this line segment ED, as X. We will define the length of AE, line segment AE, this line segment, as H. And what is the length of line segment BE? From the drawing it is very easy to see that the length of line segment BE, this line segment BE, is equals to BD minus ED. Again, BD minus ED equals to BE. I will write it down. BE equals to BD minus ED. So BE, this line segment BE, equals to BD. BD, here BD equals to M units in its length. So we substitute BD by M minus ED. ED equals to X according to our definition. So we substitute ED by X. In conclusion, we found out that BE, this line segment BE, equals to M minus X units. And what is the length of this line segment EC? EC equals to ED plus DC. That is to say, EC equals to X plus N. Okay, I write it down. EC equals to X plus N. So we write down the drawing itself that line segment EC equals to x plus n units in its length. In the next step, we will implement the Pythagoras theorem on the green triangle AED. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, in the right green triangle AED, by PT is the abbreviation for Pythagoras theorem. So in the right green triangle AD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AD, and therefore the square of the hypotenuse is AD squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to ED squared plus AE squared. Repeat again, according to the Pythagoras theorem, in the right green triangle AED, AD square equals to ED square plus AE square. AD, hypotenuse AD equals to D, so we substitute AD by D. If AD equals to D, then AD square equals to D square, and it is equals to D square equals to ED square. ED equals to X, according to definition, therefore ED square is X square plus AE square. According to our definition, AE, line segment AE equals to edge, units in itself, therefore AE square is H square. In conclusion, we found out that according to the Pythagoras theorem, in the right green triangle AED, D square equals to X square plus H square. Okay. In the next step, we will focus on the big right triangle we'll focus on triangle AEC, the big right triangle AEC. This big triangle AEC. It is partially green. Here by PT, this triangle AEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, and therefore the square of the hypotenuse is AC squared. This will be equation number 1, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AE squared plus EC squared. Repeat again. in the right triangle, triangle AEC, according to the Pythagoras theorem, AC squared equals to AE squared plus EC squared. This is equation number 1. Corresponding to equation number 1, AC is the hypotenuse AC equals to B units instead, therefore AC squared equals to B squared, and it must be equal to AE squared. AE equals to H, therefore AE squared is H squared plus EC squared. You see, we already found out that EC equals to X plus N here. Therefore, we substitute EC by X plus N. So if EC equals to X plus N, it means that EC squared equals to X plus N squared. So we found out in the volume that according to equation number 1, B squared equals to H squared plus X plus N squared. Here we will open the brackets on this side of equation number 1, of this equation number 1, and we will get that according to equation number 1, B squared equals to H squared plus X plus N squared equals to X squared plus N squared plus 2 times Xn. So according to equation number 1, we found out that B squared equals to H squared plus X squared plus N squared plus 2Xn. But H squared plus X squared equals to D squared. Here, H squared plus H squared equals to D squared. So we substitute H squared plus X squared by H squared by D squared, and we get that B squared equals to H squared plus H squared is D squared according to this equation, plus N squared plus 2 times Xn. So in conclusion, according to equation number 1, we found out that B squared equals to D squared plus N squared plus 2 times Xn. Okay. In the next step, we will focus on the right triangle, triangle AEC. In this right pink triangle, triangle AEC, we will implement the Pythagoras theorem. Triangle AEB, the pink triangle, by PT is abbreviation for Pythagoras theorem. This will be equation number 2. According to the Pythagoras theorem, in this pink right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, therefore the square of the hypotenuse is AB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AE squared plus BE squared. So in conclusion, we found out that in the pink right triangle AEB, according to the Pythagoras theorem, AB squared equals to AE squared plus EB squared. Okay. So according to equation number 2, AB equals to C, therefore AB squared is C squared, and it must be equal to AE squared. AE is H, therefore AE squared is H squared plus BE squared. We already found out that BE equals to M minus X in its length, therefore BE squared is M minus X squared. In conclusion, according to equation number 2, we found out that in triangle ABE, C squared equals to H squared plus M minus X squared. We open the brackets on this side of equation number 2, and we get that according to this equation number 2, C squared equals to H squared and M minus X squared equals to M squared plus X squared minus 2mx. Okay, so we have here two equations. In the next step, we will create equation number 3, and we create equation number 3 by multiplying equation number 1 by m, and then we'll multiply equation number 2 by n, and then we will add the two equations together. This will create equation number 3. So equation number 3 equals to the multiplication of equation number 1 by m, then the multiplication of equation number 2 by n, and then the addition of equation number 1 to equation number 2. Okay, so first of all, so according to equation number 3, we'll get that we will multiply equation number 1, this side of equation number 1 by m, so it is m times d squared plus n squared plus 2xn. So we multiplied the right side of equation number 1 by m, and then we will multiply the right side of equation number 2 by n, so it is n. In the right side of equation number 2, we have h squared plus, but before we multiply equation number 2 by n, we know that h squared plus h squared equals to d squared. Found out that d squared equals to x squared plus h squared. So we'll substitute x squared plus h squared plus s squared by d squared in this equation, equation number 2, and we get that according to equation number 2, c squared equals to h squared plus h squared plus x squared is d squared plus m squared minus 2mx. Now we will multiply equation number 2 by n, so it is n squared, and here h squared plus x squared is d squared. So we substitute h squared plus x squared by d squared plus m squared minus 2 times mx. So we actually multiplied equation number 1 by m, we multiplied the right side of equation number 1 by m, we multiplied the right side of equation number 2 by n, and then we added the two equations together. and it must be equal to the multiplication of equation on the right side of the left side of equation number 1 by m. The right side of equation number 1, here we have b squared, so it is mb squared, plus the multiplication of equation number 2, the right side of equation number 2, by n. In the right side of equation number 2, we have, in the left side of equation number 2, we have c squared, so it is n times c squared. Again, in this equation number 3, we have we multiplied the right side of equation number 1 by m, then we multiplied the right side of equation number 2 by n, then we added the two right sides with each other, and then it must be equal to the multiplication of the left side of equation number 1 by m, that is to say it is mb squared, plus the multiplication of the left side of equation number 1 by c by n. Okay, so here it is mb squared plus nc squared. Okay, so here we will open the brackets on this side of equation number 3, and we will get that according to equation number 3, md squared, m times d squared is md squared, plus m times n squared is mn squared, m times 2xn is 2xmn, plus n times d squared is nd squared, n times m squared is nm squared, and finally n times minus 2mx is minus 2mnx. Okay, and it is equal, in the other side of the equation we have mb squared plus nc squared. In this side of equation number 3 we have 2xmn plus 2xmn minus 2xmn. So this is equal to 0, of course, so we cancel the two expressions of the equation. So what is left from equation number 3 after we cancelled 2xmn with minus 2xn? In this side of the equation number 3 we have md squared plus mn squared plus nd squared plus nm squared equals to mb squared plus nc squared. So actually this is equation number 3 after we open the brackets. In the next step, we take out d squared as a common factor from this expression and from this expression. So here we get that d squared is a common factor, it's taken out as a common factor. So from this expression md squared, what is left after we took out d squared as a common factor, what is left is actually m. What is left from nd squared after we took from it nd squared as a common factor, what is left is actually n. So it is d squared m times n. In the next step we will take from this expression, we take out a common factor of m times n from this expression and also from this expression. So mn was taken out as a common factor, What is left from this expression nm squared after we took from it mn as a common factor? What is left is actually m. What is left from this expression mn squared after we took mn as a common factor? What is left is actually n. And it is equal to mb squared plus nc squared. In the next step, we take out m plus n as a common factor from those two expressions. And we'll get that m plus n is taken out as a common factor from those two expressions. What is left from this expression after we took from it m plus n as a common factor? What is left is actually d squared. What is left from this expression after we took from it m plus n as a common factor? What is left is actually mn. And is equal to b squared m plus c squared n. From the domain, it is very easy to see that m plus n equals to a. Here, bc equals to a, and bc also equals to m plus n. So m plus n equals to a. So we substitute m plus n in equation number 3 by a. Okay, so according to equation number 3, we get that m plus n is a. Inside the brackets we have d squared plus mn equals to b squared m plus c squared n. Or we found out that b squared m plus c squared n equals to a. Inside the brackets we have d squared plus mn. And this is actually Stewart's theorem. Here you can see that according to Stewart's theorem, b squared m plus c squared n equals to a. Inside the brackets we have d squared plus m times n. So we proved Stewart's theorem according to the first method. In the next step, we'll prove Stewart's theorem according to the second method. In the second method, we define angle ADB, this angle is theta, and according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, so because of the fact that BC is one side of triangle ABC, it is absolutely a straight line. So if you focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of BC at point D? We have here angle theta plus the missing angle. In total, they must be equal to 180 degrees according to rule number 1. So the missing angle, angle ADC, must be equal to 180 degrees minus theta. Why? Because 180 degrees minus theta plus theta equals to 180 degrees, exactly according to rule number 1. Okay. In the next step, we will implement the law of cosines in triangle ADB, the green triangle, triangle ADB. And then we will implement the same law, the law of cosines, in the pink triangle, triangle ADC. you the law of cosines. The law of cosines is shown in any triangle. So here, this the law of cosines. So this triangle ABC, could be any triangle. This is triangle ABC. We know that the length for side AB is A, side AC equals to B units in its length, and finally side BC equals to C units in its length. And this angle BAC equals to theta. Then according to the law of cosines, we get that this triangle ABC, that could be any triangle, C square equals to A square plus B square minus 2 times AB times cosine theta. We will add to this equation 2 times AB cosine theta, then we will subtract C square, and then we will divide it by 2 times AB, and finally we will get that cosine theta equals to A square plus B square minus C square over 2 times AB. Okay, now we'll implement the law of cosines. This law in the green triangle ABD. Okay, so in the green triangle ABD, according to the law of cosines, we will get that cosine theta equals to M square plus D square minus C square over 2 times MD. Okay, so equation number 1 is the implementation of the law of cosines in triangle ABD, the green triangle ABD. In the next step, we'll implement the law of cosines in the pink triangle ADC. So in triangle ADC, according to the law of cosines, we will get that cosine 180 degrees minus theta equals to D square plus N square minus B square over 2 times dn. Okay, cosine 180 degrees minus theta equals to D square plus N square minus B square over 2 times dn in the pink triangle ADC. We have the trigonometric identity that cosine 180 degrees minus theta equals to minus cosine theta. According to this trigonometric identity, we substitute cosine 180 degrees minus theta in this equation number 2 by minus cosine theta. And we get that according to equation number 2, minus cosine theta equals to d square plus n square minus b square over 2 times dn. Okay. In the next step, we'll multiply this equation number 1 by minus 1, and you'll get that according to equation number 1, cosine theta times minus 1 is minus cosine theta, and is equal, we multiply this side of course also by minus 1, so we have here minus, before the brackets, inside the brackets we have m squared plus d squared minus c squared over 2 times md. So according to equation number 1, found out that minus cosine theta equals to minus, inside the brackets we have m squared plus d squared minus c squared over 2 times md. In the next step, we will create equation number 3 that states that minus cosine theta according to equation number 1 must be equal to minus cosine theta according to equation number 2. That is to say, according to equation number 3, we found out that minus cosine theta according to equation number 1 equals to minus m squared plus d squared minus c squared over 2 times md equals to minus cosine theta according to equation number 2, and minus cosine theta according to equation number 2 equals to d squared plus n squared minus b squared over 2 times dn. In the next step, we will multiply this equation number 3 by 2d, and we get that according to equation number 3, in this side of the equation we have this expression. So when we multiply it by 2d, we have 2d in the numerator, we have 2d in the numerator, we have 2d in the denominator. 2d over 2d is 1, so 2d will get cancelled, and we left only with m in the denominator. The numerator will be the same as it is here, so it is minus m squared plus d squared minus c squared equals to, here, when we will multiply this equation by this side of the equation by 2d, 2d over 2d is 1, so 2d will get cancelled, so in the denominator we left only with n. The numerator will not change, it will be d squared plus n squared minus b squared. In the next step, we cross multiply this equation number 3, and we get that according to equation number 3, we have minus n. Inside the brackets, we have m squared plus d squared minus c squared. It is equals to m. Inside the brackets, we have d squared plus n squared minus b squared. In the next step, we will open the brackets on this side of this equation number 3, and we will get that according to equation number 3, minus n times m squared is minus nm squared, plus minus n times d squared is minus nd squared, minus n times minus c is nc squared, because minus times minus is plus, so it is plus nc squared. And it is equals to, on the other side of the equation we have m times d squared is md squared, plus m times n squared is mn squared, and finally m times minus b squared equals to minus mb squared. In the next step, we relate to this equation, equation number 3, nm squared, then nd squared, and then we subtract nc squared. Therefore, in this side of the equation, we left with 0. In the other side of the equation, we have md squared plus mn squared minus mb squared. And we added to this side, to this equation, nm squared, so it is plus nm squared. We added nd squared, so it is also plus nd squared, with and we subtracted nc squared, so it is minus nc squared. Okay. In the next step, we take out a common factor d squared from this expression and from this expression. And we will get that according to equation number 3, so this square was taken out as a common factor from this expression, so inside the brackets we have m, and also from this expression, so inside the brackets we have n. And then we'll also take out mn as a common factor from this expression and from this expression. So nm is taken as a common factor. Inside what is left from this expression, after we took from it nm as a common factor, what is left is actually m. And what is left from this expression after we took from it mn as a common factor, what is left is actually n. And we have also minus mb squared minus nc squared. That is equal to 0. Okay. So in this equation, we will add in this equation, equation number 3, mb squared plus nc squared. And we get that according to this equation, equation number 3, d squared m plus n plus nm m plus n equals to b squared m plus c squared n. Okay, we added mb squared and nc squared to this equation, equation number 3. In the next step, we will take m plus n, we take out m plus n as a common factor out of those two expressions, and we will get that according to this equation, equation number 3, m plus n was taken out as a common factor from those two expressions. So in this expression we left only with d squared, in this expression we left only with m times n. And it is equals to b squared m plus c squared n. We already found out in the first method that m plus n equals to a. Yeah. It's very easy to see that m plus n equals to a. Therefore, we will substitute m plus n by a. And we get that according to this equation, equation number 3, m plus n is a. Inside the brackets we have d squared plus mn and is equal to b square m plus c square n. And this is exactly Stewart's theorem. So we proved Stewart's theorem in both methods. In the next step, I will summarize the lecture. We start, of course, with the first method. In this lecture, we proved Stewart's theorem in two different methods. In a nutshell, Stewart's theorem yields a relation between the lengths of the sides of a triangle to its CVN. The CVN in this triangle ABC is line segment AD. And it is equal to the unit in its length. And according to Stewart's theorem, I'll show you it in the okay, so here, according to Stewart's theorem, in any triangle, this triangle ABC could be any triangle. The CVN in this triangle ABC is AD. The length for side AB is B units. The length for side AB is C units. Side BC equals to A units in its length. Line segment BD equals to M units. And here, line segment DC equals to N units in its length. According to Stewart's theorem, the following equation is true: that b squared times n plus c squared times n equals to a, and then we will open the brackets. Inside the brackets we have d squared plus m times n. Again, b squared times n plus c squared times n equals to a. Inside the brackets we have d squared plus n mn. Okay. So, in order to prove that this equation is true, we did in the first method a construction from the vertex A of triangle ABC. We draw perpendicular on side BC, on BC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point A and BC as E. We defined this line segment AED as X. We defined line segment AE as H. And here, line segment EC equals to X plus N, and line segment BE equals to BD minus ED. BE equals to BD minus ED. Again, BD minus ED equals to BE. So BD equals to M. BD equals to M. So we substitute BD by M and ED equals to X. We substitute ED by X. In conclusion, we found out that EC equals to M minus X. And there we found out that BD equals to M minus X, and we also found out that EC equals to X plus N. Okay. In the next step, we implemented the Pythagoras theorem on this right plane triangle, triangle AED. On the right triangle, triangle AED, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AD square equals to ED square plus AE square. Repeat again, in the right triangle, triangle AED, AD square equals to ED square plus AE square. So, the hypotenuse AD is D, therefore AD square is D square, and ED equals to x, therefore ED square is x square, and finally AE equals to h, according to our definition, therefore AE square is h square. In conclusion, we found out that d square equals to x square plus h square. Then we focused on the right triangle, triangle AEC. On this right triangle, triangle AEC. According to the Pythagoras theorem, in the right triangle AEC, AC square equals to AE square plus EC square. Repeat again. In the right triangle AEC, AC square equals to AE square plus EC square. Okay? So, AC is B, therefore AC square is B square. AC square is B square. AE is H, therefore AE square HS is H square. And finally, EC, line segment EC equals to X plus N, therefore EC square is X plus N square. In conclusion, we found out that according to equation number 1, B square equals to H square plus X plus N square. We open the brackets on this side of equation number 1. We found out that B square equals to H square plus X plus N square. X plus N square equals to X square plus N square plus 2 times Xn. We already found out that H square plus H square equals to D square. Therefore, we can substitute H square plus H square in this equation number 1. By D square. We did it here and we found out that B square equals to H square plus H square equals to D square. We have also here N plus N square plus 2xn. Okay, so according to equation number 1, B square equals to D square plus N square plus 2 times xn. In the next step, we focused on the pink triangle, the pink right triangle, triangle AB. We implemented the Pythagoras theorem on the right pink triangle, triangle AB. According to the Pythagoras theorem, in the pink right triangle AB, AB square equals to AE square plus BE square. Repeat again. In the pink right triangle, AB square equals to AE square plus EB square. AB equals to C, therefore AB square is C square. AE equals to H, therefore AE square is H square, and finally EC, this line segment EC or side EC equals to M minus X, therefore EC square equals to M minus X square. EB square equals to M minus X square. In conclusion, according to equation number 2, we found out that C square equals to H square plus M minus X square. We opened the brackets on this side of the equation number 2 and found out that according to equation number 2, C square equals to H square plus M minus X square. M minus X square equals to M square plus X square minus 2 times MX. Again, we have here H square plus X square that is equal to D square, so we substitute H square plus X square by D square. So, in conclusion, according to equation number 2, we found out that C square equals to D square plus M square minus 2 times MX. In the next step, we created equation number 3 by multiplying equation number 1 by M, then we multiplied equation number 2 by N, and then we added the two equations with each other. In this way, we created equation number 3. So here in equation number 3, we multiplied the right side of equation number 1 by M. Here, in this equation number 1, we have the right side of equation number 1 multiplied by M. So it is M, inside the brackets we have D square plus N square plus 2 times Xn. Then we multiplied the right side of equation number 2 by N. In the right side of equation number 2 we have h squared plus x squared plus m squared plus 2xn. And here we multiplied the right side of equation number 2 by n. So it is n times d squared plus m squared minus 2x mx. Then we added the two equations together, and this way created equation number 3. And in the next step we multiplied also the left side of equation number 1 by m. In the left side of equation number 1 we have b squared. So it is m times b squared. And then we multiply the right side of equation number 2 by n. In the right side of equation number 2 we have c squared. So it is nc squared. And then we added the two equations together. That is to say it is mb squared plus nc squared. So this is equation number 3. That is actually the multiplication of equation number 1 by m. Then we multiplied the equation number 2 by n, and then we added the two equations with each other. This way we created this equation number 3. In the next step we open the brackets on this side of equation number 3 and found out that mb squared plus mb squared plus mn squared, or md squared plus mn squared plus 2 times xmn equals to nd squared plus nm squared minus 2 times mxn, and it is equal to mb squared plus nc squared. So here we have plus 2xmn, and here we have minus 2xmn. Therefore it is equal to 0, of course, so those two expressions will get cancelled. What is left from equation number 3 after we cancel the two expressions? What is left actually? Here we have, in this side of equation number 3 we have mb squared plus mn squared plus nd squared plus nm squared equals to mb squared plus nc squared. In the next step we took out d squared as a common factor from those two expressions. So inside the brackets we have m plus n. Then we took out mn as a common factor out of those two expressions. So inside the brackets we left with m plus n. In this side of the equation we left with mb squared plus nc squared. Then we took out n plus m as a common factor out of those two expressions. So inside the brackets we have d squared plus nm, and it is equal to b squared m plus c squared n. We know that m plus n equals to a, so we substitute m plus n by a in this equation number 3. So n plus n is a times d square plus mn equals to b square m plus c square n. Then, so we found out that b square m plus c square n equals to a. Inside the brackets we have d square plus mn. This is exactly Stewart's theorem. Then we prove Stewart's theorem according to the second method. In the second method, we defined angle ADB as theta, therefore angle ADC equals to 180 degrees minus theta according to rule number 1. Then we implemented the law of cosines in the green triangle ADB and in the pink triangle ADC. According to the law of cosines, in this triangle ABC, cosine theta equals to a squared plus b squared minus c squared over 2 times AB. Then we implemented this law, the law of cosines, in the green triangle ADB. ABD. According to the law of cosines, in the green triangle ADB, cosine theta equals to m squared plus d squared minus c squared over 2 times md. Repeat again. Cosine theta equals to m squared plus d squared minus c squared over 2 times md. Then we implemented the law of cosines in the pink triangle ADC. According to the law of cosines, cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times nd. I repeat again, cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times dn. According to the trigonometric identity that cosine 180 degrees minus theta equals to minus cosine theta, we can substitute cosine 180 degrees minus theta by minus cosine theta. We did it here, and we got that minus cosine theta equals to d squared plus n squared minus b squared over 2 times dn. Then we multiplied equation number 1 by minus 1. So cosine theta times minus 1 is minus cosine theta. And then we have minus, inside the brackets we have m squared plus d squared minus c squared over 2 times md. Then we created equation number 3 that states that minus cosine theta according to equation number 1 must be equal to minus cosine theta according to equation number 2. That is to say, minus cosine theta according to equation number 1 equals to minus m squared plus d squared minus c squared over 2 times md. And it must be equal to minus cosine theta according to equation number 2, that is d squared plus n squared minus b squared over 2 times nd. Then we multiply this equation number 3 by 2d. So here 2d we get cancelled, we left only with m in the denominator. The numerator will not change, so it is minus m squared plus d squared minus c squared over m. We multiplied also this side of the equation by 2d, so 2d over 2d is 1, so 2d we get cancelled. In the denominator we left only with n. The numerator will not change, so it is d squared plus n squared minus b squared over n. Then we cross multiply this equation number 3, and we found out that minus n times m squared plus d squared minus c squared equals to m. Inside the brackets we have d squared plus n squared minus b squared. Then we open the brackets on both sides of equation number 3 and found out that minus n times n is minus n m squared, minus n times d squared is minus n d squared, and minus n times minus c squared is nc squared, plus nc squared, because minus times minus is plus. It is equal. In the other side of the equation number 3 we have m times d squared is md squared, m times n squared is mn squared, and finally m times minus d squared is minus md squared. Then we added to this equation number 3 nm squared. We added also nd squared, and we subtracted nc squared. So in this side of the equation we left with 0. In the other side of the equation we have md squared plus mn squared minus mb squared. So we added mn squared, we added nd squared, and we subtracted nc squared. Okay, and we got this expression. Then we took out d squared as a common factor from those two expressions. So inside the brackets we left only with m plus n. Then we took out m times n as a common factor out of those two expressions. So inside the brackets we left only with n minus n, and we have also minus mb squared minus nc squared equals to 0. Then we added nc squared plus md squared to this equation and found that this squared times m plus n times m plus n, nm plus nm times m plus n equals to b squared m plus c squared n. Then we took out n plus m as a common factor from those two expressions. Inside the brackets we left only with d squared plus nm, that is equal to b squared m plus c squared n. We have already found out that m plus n is a, so it is very easy to see it from the drawing. I'll repeat again that m plus n equals to a. So we substitute m plus n by a in this equation number 3, and found out that m plus n is a. Inside the brackets we have d squared plus mn equals to b squared m plus c squared n. And this is exactly Stewart's theorem. So we succeeded to prove Stewart's theorem in two different methods. Okay? Thank you very much.